keep the integrity of our classroom going, Monday, Wednesday will be our blue days. Tuesday, Thursday will be our white days for pre-calc. So we're going to do a quick little lesson on sum and difference identities, as you can see here. So if you want to find the sine of alpha plus beta, which is here, alpha and beta just represent your angles, then we're simply just going to replace the alpha and the beta with some of the angles that work around our special right triangle. So here I provided a list for you to make it easy. And if you think about your 30 degrees, 60, 90, your 45, 45, 90s, okay? These are the variations of all the different angles that we graph in the coordinate plane that involve the 30, the 60, and the 45s. So our job is to come up with this angle measure of 15 degrees using either a sum or a difference. It doesn't matter which, unless I specify to use a sum or a difference. So here what I'm going to do is use a difference of two angles, since we don't have 7.5 degrees and 7.5 degrees, right? That's kind of silly of us, because we're using the special right triangles down here below. So how about if we try something like, let's say a 45 degree angle minus the 30, that will get us 15. We're going to rewrite our statement. A little improvising here, so bear with me. Using the wonderful iPhone, of course. So we're going to do sine of 45 minus the sine of 30. We're going to slip that into the difference identity for the alpha and beta. And then we're going to rewrite the sine of 45, the cosine of 30, etc. And we're going to graph it using our special right triangles and get those ratios, and voila. So let's give this a go. So that's going to equal, this is alpha, this is beta. So we're going to put that into sine 45 cosine 30 minus cosine 45 sine 30. Now what we're going to do is we're going to graph each of these respective angles, as we have done in the past, our bow ties. So 45, 1 radical 2, 30, 1 radical 3, 2. So now let's use the appropriate measures of the ratios for the sine of 45, which is 1 over radical 2 times the cosine of 30, which is radical 3 over 2, minus cosine 45, 1 over radical 2, and the sine 30 is 1 over 2. Multiplying the fractions, leave it in simplified radical form. And now what we want to do is subtract, since we have the same denominator. We have radical 3 minus 1 all over 2 radical 2. Next job is to rationalize the denominator, and we should be done very shortly. Use your distributive property in the numerator. So it's radical 6 minus radical 2. The square root of 2 times 2, of course, is the square root of 4, or 2. So if you take that 2 and multiply it by 2, you get it all over 4. So that's what the sine of 15 degrees is, using a difference identity.